Okay, well, we've seen a video example, and then there's another one here, a third one in which you can try it out, and a fourth one, and a fifth one, and then some ones that are more, that have more premises, and 5 premises and sort of a little bit longer one, and then another one here. Okay, now, and we're going to go and do some more examples. There's an exercise sheet, and I also want to alert you to what's on RiggX for this week. So you've just completed last night the propositional logic extra, or earlier, hopefully this one, and the consistency and paradoxes. And we have a new set for this week that's due on February 19th. And that is this coming Monday night at midnight. Okay, let's look at these problems. First, there's already a video with the primary patterns. And then this is like one of those ones, one of the exercises in the text. And then here's what we've just gone over about a Gimli. In fact, this is probably another video of exactly this stage. And then here is Gimli makes fire. Did Gimli dance? Did Gimli read a book? Does Gimli see? These are all the exercises in the text that I give you, this part here and this part here, and you're supposed to fill in this. That you fill in one of these blanks with one of these justifications. So you don't actually have to construct the proof, right? And again, this is the same one, but with a longer proof. And here is another one with a longer proof, different context. And the last one is there's a project exercises, okay? So this is one of the project exercises. So let's look and see what those are for this section before going further. At the end of this, we have a section on proof patterns, and I'm jumping over that in the text. The proof patterns here, because we've all been doing it so far, direct proofs, but there's other proof patterns which all are related to rules of inference. So for example, direct proof is related to affirm premise, indirect proof, deny conclusion, proof by contradiction, deny conclusion, verifying all possible cases is like common outcome. This one is create combination. There's one that skip middle, create alternative. And there's an example here that shows you that calculations are kinds of are in a way proofs that you've already been doing this kind of stuff. Okay, a math example. But at the end, there is a project, deductive patterns and direct proofs. And all this is there's some directions at the beginning, but then there's these larger examples. For example, here is, so they're like Gimli proofs, but they're longer. Now, these ones require more understanding of what you require the discovery diagram, the proof discovery diagram is more helpful here. And then there's more discussions of that. And here I show you the diagram, and there is okay, like I think the one in the project one that on RiggX that I was referring to, this refers to one of the project exercises. Did Hector go fishing? Well, you have to, here's the one, did Hector go fishing? So it refers, so you might not see, you might have to go through. The idea is that you should go through and work these project exercises as practice. And there are four, and that's what it is. The project is just to practice these exercises. And we can, and then there's one here where you download a PDF, you construct the argument, and then put the answer on Piazza. So those are your exercises, your participation exercises for this week. And the idea is that I want you to do it this week because this is part of coming to class and engaging in the material and working on it this week. So that's why we don't do like late work on this stuff, because it's work that you do during the week. It's your participation score for the semester for this week. Okay. Um, so there are, just as a comment, since we've broken our uh, scheme of presentation, there is another document on um, Piazza about proof patterns, which are they're like larger scale. They're ways to organize proofs, and there's also some moves in it that are not just logical steps, but are sort of like introductory steps, because a proof is sort of like an essay or a presentation, and rather than just a list of logical steps. The proofs that we've seen so far are sort of like the proofs you might have done in ninth grade geometry, where you had a list of axioms and you wanted to prove statements and you gave a list of steps and then justified them with the axioms. And so that was your introduction to axiomatic proofs. And this is sort of the continuation of something in that spirit, although it's not with geometry. But then when you actually write a proof, it's like it's like written in sentences of mathlish, this sort of combination of math and logic, which you find in math texts. And there's different moves, like choosing names. You identify assumed background properties that you can use without comment, like all of high school algebra, or properties of integers or real numbers. Maybe you want to prove those, but maybe in most contexts, you just want to take them as known properties. Um, and there's other statements here that we haven't come to yet, but that we will, and that a lot of them follow. Um, this has to do with sets. So I just wanted to alert you to the existence of that, although it won't all make sense right away. Okay. Um, so let us now continue with one of these larger examples. Okay, so let's say look at number 4 here, and let's do this. I can do this in external, so we can this one's partially completed for you, but let's do this next one, which is a little bit longer. It's I talked with here's the argument, or the statements we have. We have 1, 2, 3 premises and a conclusion. Oh, well, actually, this is 4 premises and the conclusion. We want to know a result here. So if I talk with George on the field or at the party, I talked with George at the party. If I talked with George at the party, then I talked with the Red Sox. If I talked with George on the field, then I talked about the Celtics. If the Celtics, if I know that I did not talk about the Celtics. So the question is, did I talk about the Red Sox? Well, it seems that you did, because you didn't talk about the Celtics. So let's tentatively answer yes. Okay, and proceed with the argument and see. So we have, I've chosen 4 letters for you: field, party, Red Sox, Celtics. So the field is here. Let's zoom in a little bit. And I thought maybe sometimes if you don't have enough space, sometimes it's useful to change the font size here to a smaller font size so that your stuff doesn't overwrite. I talked with George on the field, so it fits in the blank. P is I talked with George at the party. Now you can see that, like, I talked with George at the party is sort of embedded in this first one, but it's more complete here. Now R is I talked about the Red Sox, and C, I talked about Celtics. Okay, so then what is each claim? Well, we have the first one is going to be field or party, so it's going to be F or P. And so we'll want to do F. Here's the other one, W or P. Yeah, there's some more LaTeX is and just in case, we can do the and as an unusual name two as wedge. So this is like our logical or, and this is our logical and. Okay, so we have over here our first proposition. I talk with George at the field or the party is F or V. And then the next one is if I talked with George at the party, then I talked to the Red Sox. So that is P implies R. What P, right arrow R. And then next one is F implies C. Arrow C. Oh, that's a little bit too large. There, okay. Well, it's still a little bit. There, okay. Now, the last one is I did not talk about the Celtics. So that would be neg C. To get this little thing, I'm typing this sigma here, which is sort of a math, it opens the little LaTeX editor. There. Well, that's again, it's a little bit large. Okay, so now I have the claim symbolically. And the thing to do is to then do a discovery diagram to understand how to organize the proof. So what I'm going to do is write this horizontally, write F or P, but then write all the implications like I did last time vertically. So P implies R, and F implies C, and not C. So this is something I know definitely, right? So that interacts with this chain. You can sort of see there's like a a pathway here, right? Of connections. Now I want to know, I want to tentatively prove that R is true, given that this pathway of connections exists and that not C is true. So that informs me of how I might want to go. And you can sort of see that I have not C, and F implies C is going to be a deny conclusion, from which I'm going to get not F. And then F or P and not F, that's deny option. That's going to get me a P, and P implies R with a firm premise will get me R. So I can see that I can follow with logical moves all of that around. And so this argument is just organizing the steps that you have discovered in this diagram. So I could start here with not C, right? And just so I don't, let me just do this. If you have a graphics tablet, I want to edit, undo, move there. Okay, so I don't have to sort of keep cutting and pasting and moving these things. I could just draw this as not, oh, let me do it in black though. Okay, so I have not C. That's premise A, B, C. Well, let's not use that. They are premises 1, 2, 3, and 4. This is premise 4. Then I can write down F implies C. That's premise 3. And you can see that this pattern here, I've denied the conclusion of an implication, so I can conclude not F according to deny conclusion. Then once I know not F, right, I could write down here F or P. That is, I know that's true, or I'm assuming that's true because of premise 1. Then F or P and not F, that's deny option. So if F or P and not F, I can include P by deny option. And then if I know P, I can use writing premise 2 here, premise 2, and then I've affirmed the premise of an implication, so I know that R is true by affirm premise. And this also shows that I've written these out maybe with more steps than you need, because you don't need these ones here. And so you don't have to use all the steps. You might have organized this in a different way. Some ways of organizing this require more steps than others. So I just want to leave room and not prejudice how you do it. Well, and here we see that indeed this is a sound argument that if these first 4 propositions are true, then I did talk about the Red Sox. And R is the proper conclusion. So you can say that these premises imply or lead to the conclusion that you talked about the Red Sox. Okay, and this is okay, and this is C page 179 annotated. I will put this on Piazza. Okay, so this is this represents almost everything we need to do this week in for this material. So I think things are going to settle down now to where we have less. We sort of what our project, our material and project each week will be a little bit more focused, and she'll have less confusion of sort of seeing what you have to do. Because what you have to do is read the text, chapter 3, this part of it, the direct the chapter 3, and then do some of the exercises of the text, and check with the RiggX exercises, complete those by Sunday, and then that way you will be ready for the this stuff, which will appear in the first demonstration. And let's go and look at when that will be, because it isn't in let's sort of to wrap up. Here we are with demonstration 1. Will not be at the end of this week. It'll be the end of next week. Here we're going to have a second version of Concept 1. But demonstration 1 will include stuff on patterns of deduction, consistency and paradoxes, and more stuff about logic than Concept 1 did. So demonstration 1 sort of covers everything that we've done before. It might have a Guido problem on it. It has Sudoku. It has the Valley of Logical Despair problems, logical paradox problems. It might have a few basic questions about sets, which will start next weekend. This is a shorter week because we don't have February 19th. So our first, but I mean, our class will be the same length because it'll be Tuesday and Thursday, and then we'll have demonstration 1. And then we have a little bit more logic, which is in sets and properties. We have the logic of properties, which will complete the stuff about proofs here. So once we complete sets, this whole sort of segment of logic and sets forms a good foundation for almost all of mathematics, for linear algebra, for discrete math, for the math needed in computer science. So it is an important sort of foundation that when you go to a 4-year school, they will assume you understand all this stuff. So it's going to be worth your while to spend the time to become familiar with it and understand the logic and all that. Hopefully the exercises will be relatively interesting. And I think since it's about 12:30, and usually if you were more people present, then there'd be more questions. But I think we can stop here, and that will be it. And I hope to see you on Thursday. And good luck shoveling the snow that maybe isn't there so much.